Thank you for joining us at this early hour. I'm Marina Jurica of the JPL News Office. Ingenuity is a technology demonstration, which means it is a proof of concept experiment. After years of development on Earth, the team has 1 month to test the technology on Mars. Tonight, we'll talk to a few team members and then keep our eyes on the room where the helicopter operations team will be receiving and studying their data. To assist us in that room is one of the Ingenuity helicopter engineers, Taryn Bailey, who will help guide us through the steps the helicopter team is taking to see the results of their first flight and begin the month of ingenuity. Welcome, Taryn.
Hi, Marina. Thanks so much for having me. Super excited to be here. It's flight night. Woo!
Yes, it's flight night. You had an integral part with the helicopter team. Can you tell us about your role?
Yeah, so I'm a mechanical engineer, and I helped in the assembly, integration, and testing of the Ingenuity vehicle. And it was really important that we simulate a Mars-like atmosphere in our testing. And in doing so, we knew it would give us the best chance to execute a real flight on Mars.
And that's not an easy feat. Flying on Mars is much different than flying on Earth.
Very difficult. It's less than 1% of Earth's atmosphere, making it very difficult to fly and generate enough lift.
So, Taryn, what is the Ingenuity team preparing for right now? What are they waiting to see?
We're waiting to see data confirming that we executed our first flight. The actual flight on Mars took place earlier today, and that's because Mars is over 178 million miles away, so there's a little bit of a delay. The data is expected to hit the Deep Space Network at about 3:34 a.m. Pacific time, and we'll start processing the data shortly after that to see how we did.
Fingers crossed. Thanks so much, Taryn. We'll be coming back to you shortly as we get closer to the start of the data downlink. What started out as a dream is now becoming reality for the Ingenuity helicopter team. Let's take a look at their journey.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time in an experimental aircraft.
Okay, so basically, Perseverance, when it... Oh. Morning, guys. Weaver, John C. I know the sound quality sucks right now, but that's alright. It's about 3:18 in the morning, Pacific Standard Time, Monday. It's the 18th of April, 2021. Why is this recording so unusual? And why am I without the damn headsets? Well, I wanted to capture on another computer of what's been happening on the NASA satellite that launched to Earth a couple of years back, landed on Mars, and now roving around, called Perseverance. One of many satellites that Earth has dumped on Mars to take a look at the planet, see how screwed up the damn place is, how dry in hell, lack of oxygen, but enough rock information to keep the rock hounds happy. Also, if there's any possibility of any ancient sign of life, which would freak everybody else out if we actually found it. Well, the reason why we got our satellites out there is to find that information. One of them is a satellite called Perseverance, which we put a helicopter package into it. And it has taken about a couple of weeks for the damn thing to get powered up. They need sufficient enough energy on it and enough lift in the atmosphere to make a first flight, the very first flight. Right now, we're waiting for the information sent over to us a couple of hours ago. They're still trying to process it. They're trying to wait for the first of it so they can take a look at it. Now, it's not like a damn image where we see the satellite and its legs or its wheels. This is an aerial shot. We needed the information to see whether it powered up. And if it is sufficiently powered up, did it take off? And once it took off, did it crash and burn, or did it actually started taking videos and audio and everything else it needs to do? And once they get that information, they'll be sending that information over within 30 minutes. Now, I'm going to turn this thing up.
Moved it onto the Perseverance rover, so a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that could be the mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
NASA has to get dramatic in this video, in this music.
Along with your cup of coffee, you can join in on the conversation by asking the helicopter team questions at NASA JPL on all social platforms by using the hashtag MarsHelicopter. We will get to your questions later on in the program. Mimi Ong is the project manager for Ingenuity. She joins us now as they wait for the downlink to start. Welcome, Mimi. Good morning.
Hi, good morning, Marina.
Now, Mimi, this has been quite the journey for you and your team. How do you feel finally reaching this moment?
Our team has been working on the Mars helicopter for over 6 years, and for some even longer, towards this ultimate dream of experimenting the first flight at Mars. Here we are.
Yes, here we are. And last week was a little bit of a week for you guys. You've had some technical challenges. What made you decide to go ahead with the first flight attempt this morning?
April 9th was a surprise. We were 2 days away from first flight and just onto our very last checkout, high-speed spin of the rotor system. And there we discovered an intricate timing issue that was preventing the helicopter from transitioning to flight mode, the mode that we need to be in to spin the rotor system high speed. So right after we found that, our team went into high gear, identified 2 possible solutions in a couple of days, and we picked the solution that is really the most simple, most straightforward option. So a note there, though, that the solution that we've adopted, it does transition to the helicopter into flight mode about 85% of the time. So when we go to flight, and if we don't go into flight mode, the helicopter will stay safe, and we will attempt the first flight again. So just last Friday, we took the solution, applied it to Ingenuity, and successfully spun Ingenuity's rotor system full speed. So next step is our first flight attempt now.
And to give folks at home, Mimi, some perspective, the goal is to fly on a planet that has just 1% the atmosphere of Earth. And you're controlling that flight from over 100 million miles away. How difficult is that?
Very, very difficult to fly a rotorcraft at Mars. You know, a rotorcraft pushes the atmosphere to generate lift. And when there is that little atmosphere, the rotor system has to spin really fast. In fact, we'll be spinning over 2,500 revolutions per minute for this flight today. And Ingenuity is less than 1.8 kilograms, right? 4 pounds. And in that 4 pounds, Ingenuity has to be able to fly in that very thin atmosphere and be able to survive and operate autonomously at Mars. For example, Ingenuity, our little 4-pounder, has been on the surface of Mars, keeping itself warm throughout the cool nights, down to minus 130 degrees Fahrenheit, and it's been doing that every day. So, on top of that, our flight experiment at Mars, we are operating it all the way back here from Earth. So, yeah, it's very challenging, but we're ready.
Oh, Ingenuity is small, but it is mighty, and the team has come so far already. What other milestones has the helicopter team already achieved before this morning?
Ingenuity has passed all of its milestones leading up to the first flight. So, performed perfectly during cruise, survived the drop, and has been charging itself with high, good energy levels. Each time it's been communicating daily to the base station and keeping itself warm. And with the rotor system all checked out to full speed, Ingenuity is ready to go. And at the high level for the Mars Helicopter Technology Project, we have 3 goals that are in line with NASA's agency level objectives. The first is to demonstrate here on Earth that it is possible to fly a controlled power flight in the thin atmosphere of Mars. We've done that. The second objective is to perform that actual flight at Mars. Well, we're about to get data back very soon here on that first flight. And the third is to return data to inform engineers working on designing future generations of Mars helicopter. We have received valuable information data back since we've dropped on the surface. And tonight's data from the first flight will be extremely important. So we're ready to go.
We are ready to go. Now, what is success going to look like for you guys tonight?
So there are 5 scenarios. Okay, so if the solution we implemented successfully transitions the helicopter to the flight mode, we'll be all right. But if it doesn't transition, then we will be attempting the flight again tomorrow. If we don't get to flight mode tonight, then we'll go on. If we go successfully to the flight mode, there are 4 scenarios. Full success in flight. Second scenario could be partial success in flight. The third would be not having sufficient information, in which case we'll need more time to determine what happened. The fourth could be failure. So whatever the outcome, we are set here to learn.
And a bright future is ahead, Mimi. The risk is huge, but the reward is high. We will all be rooting for your team. Good luck.
Thank you, Marina.
As we get closer to the data arrival, let's talk to Tim Canham, Ingenuity Operations Lead. Thanks for joining us, Tim.
Thanks, Marina. Glad to be here.
Now, how does the data even get here from the helicopter to the team?
Well, they say sometimes it's complicated, right? So the helicopter does not have a radio that can talk directly to Earth, so we need the help of the rover. As a matter of fact, the rover has an instrument on board which is also built by the helicopter team called the helicopter base station. The helicopter base station has a radio which talks to the helicopter. So as you have heard, earlier today the helicopter flew. As it was flying and after it landed, it transferred its data to the base station. And then the rover takes the data from the base station and transmits it to an orbiter. That would be the MRO orbiter. And the MRO orbiter turns to Earth and then sends all the data to the Deep Space Network. At that point, the Deep Space Network itself turns around, sends it to JPL and then to the ground data systems. At that point, when it shows up, our team can take that data and decode it and see what happened during the flight.
It sounds like it has to be well choreographed, Tim. How do you plan the first flight? It's a remote autonomous operation. What goes into the planning and the execution?
Well, we've done it all as a team, as we have all along. It's been a challenge with COVID to be remote, but we learned new ways to work together. We're a small team, but we're a fast-moving team. We practiced all of these things over the course of the last year, from getting the data from the rover to decoding it to interpreting what it meant. And as we got to Mars, when the rover landed us safely, we were able to start our survey for Wright Field, and we found it fortunately right near where we landed. And so working with other instruments on the rover, like the weather instrument, and Z-Cam, which is this beautiful camera to take pictures, we planned our flight. The flight will be about 40 seconds long. We'll lift off, we'll pivot towards the rover, and then we'll land. It's going to be a very basic flight, we want to do the very basic things first to make sure that we can do our flight. And then at that point, we will get all our data back and look at it. But we had to practice all those things. And we've been using this time on the surface to get familiar with the vehicle and how it operates and work around those various troubles that Mimi talked about, and the team is ready to go.
And Tim, what specifically will the helicopter team be looking for as we go through this morning?
So one of the great things about this helicopter is it has a very powerful processor. It's tiny, but it's powerful, and we get lots and lots of data. The processor itself is about 100 times as powerful as the processor, even on the rover. And so we get all this data, as I mentioned, that gets sent to the rover, and then the rover sends it to us. So as our downlink lead, Michael Starr, sees that data arrive in the data center, he will decode it and look for it. He will look for the successful arrival of the data. At that point, we turn the data over to Hobart Grip, our chief pilot, and he will look at the portion of the data that relates to how the flight went. There are a series of events that the helicopter sends as it transitions through each stage of the flight. And when Hobart is able to verify that the progression went as planned, then he'll turn to the actual data and look at a plot of the altimeter, which is one of the instruments used in navigation. We should see the plot of the altimeter go up to the flight height and then come back down again, and that will be a positive confirmation that we got it. And finally, from the helicopter side, we are snapping a series of black and white downward facing pictures as the helicopter comes in for landing. So if everything goes well, we should see some of those landing pictures and be able to look at them on the screen. So Hobart will display those as well. And then finally, if all goes well, there should be, at the same time our data is coming down, there should be data coming down from the Z-Cam instrument that I mentioned. The Mastcam Z, a really powerful camera system that's going to try and capture us in flight. So if they were able to capture that moment of flight, then they will be able to display those images on their screen and be able to see a quick view of how the helicopter flew. That's how it's going to go.
Well, Tim, we can't wait to see those photos for sure. Thank you so much, and good luck to you.
Thank you.
We will get back to the action in the room in just a moment. Now joining us is Associate Administrator of NASA's Science Mission Directorate, Thomas Zurbuchen, who is here at JPL for the helicopter's first test flight. Welcome, Thomas.
I'm so glad to be here, Marina. Hi.
Hi. Now, how important is tonight to space exploration?
Oh, it's technology demonstrations are really important for all of us. You know, it's really taking a tool that we haven't been able to use and put it in the box of tools that is available for all of our missions going forward at Mars. So for me, it's really exciting.
Okay, so basically what they're saying is a simple up and down maneuver. Helicopter goes up, takes a little bit of a pan, comes right back down. The information sent over from the helicopter to the base station of the satellite, as explained. And the satellite, Perseverance, shoots it up to the orbiter. The orbiter shoots back over to Earth. And then Earth's going to take its time in trying to process all the data they can so they can take a look and see whether or not the ship crashed and burned or was it actually done successfully. And if it's done its programming job, if there's been no other variables that they hadn't counted on, like maybe wind shear or something like that, and believe me, they do have dust storms on Mars. Very bad ones. And if there's nothing wrong with it, everything works out all right. So far, they haven't had any issues.
And, you know, this was such a big challenge for us to embark upon as a team. And we are such a small and close-knit team. So it's really great to be back in the room with all of my colleagues and my teammates. We're all here in support of one another. We have Bob Valram watching, and he's been the vision behind this. So from the very beginning, so we have such great leadership on this team, and very excited to be here.
Yeah, enthusiast.
And we're going to be hearing from a lot of people, Terrence. So can you let us know who we're going to be hearing from as we progress through the morning?
Yeah, so first hear from our downlink lead, Michael Starch. And he's going to be the person that first lays eyes on the data. And when he receives it, he'll unpack it, he'll run through a data receival procedure, make his call-outs, and then he'll hand it over to our guidance, navigation, and control lead, also our chief pilot, Havard Grip. He'll interpret that data and display an altimeter plot to indicate if we flew. Some other voices we'll hear on VOCA will be our Deputy Ops Lead, Teddy Zenetos, who will report on the battery status, and our Systems Engineer, Jaco Karas, who will report on the motor health.
And we're going to be taking a couple of your social media questions right now as we wait for Michael to make that announcement that the data is coming in. So, Taryn, a man named Flo on Instagram asks, why did we send a helicopter to Mars in the first place?
Great question. Why not? Just kidding. Sending an aerial vehicle at this stage especially, you know, we have sent 5 rovers to Mars, and now we have an aerial dimension, which Dr. Zurbuchen pointed out that it's really important because it elevates the next stage of space exploration. And we can do more science with it. It can be a coordinated effort for future missions. It also opens the doorway for human exploration, and the helicopter can go into areas where the rover can't. So there are a lot of caves, and the rover has to overcome a lot of obstacles on the ground that the helicopter can ideally move around, and that's why it's such a great option for putting an aerial vehicle on another planet.
And as Tim mentioned, it has to be well choreographed, this flight. And so Elio on Instagram asks, why is the first flight only vertical?
So every flight we're going to build upon it, but this first flight, our mission success criteria is really to demonstrate that we can fly. And so that's why this first flight is really all about being able to demonstrate that we can fly on another planet. And so that means we'll do a 3 meter hover above the Martian surface, touch back down to signal success, and then we can advance from there.
And getting back to what everyone's going to be looking at, you had mentioned that Hobart is going to be looking at a plot. What exactly is that going to look like? Is it easy to see if the flight actually took place?
Yeah, so his altimeter plot will indicate a peak, and we'll start off with a flat line, indicating that we were grounded. Then we'll spin up and it'll have a steep incline to show that we've risen. And then at the top we'll have a dwell where we're hovering, and then another steep decline in the graph to show that we've touched down. So it should be pretty cut and dry to see that we have successfully flew.
And this morning, of course, as you mentioned, the helicopter flew a few hours ago, and we're waiting to see if it did happen. But you did a whole lot of testing here on Earth before you sent Ingenuity up there. Tell me what it was like to test the helicopter and simulate that Mars environment.
Absolutely. So just because
stay up.
the helicopter is the first of its kind, the testing also is very similar in that way. We had to simulate a Mars-like atmosphere by using very large thermal vacuum chambers to allow us to control the temperature and pressure, so we can simulate a Mars-like atmospheric density. Then we also created a gravity offload system that compensates for the difference in gravity between Earth and Mars. In addition to that, we validated a lot of our requirements with engineering models. So these are developmental models that we made, and they went through extensive environmental and aerodynamic testing. And so they were the precursors to our flight vehicle, which is, of course, currently on Mars.
And as Mimi mentioned before, it had to be super light and super fast. Why is that?
Flying on Mars is very difficult. You guys have heard it before. It's less than 1% of Earth's atmosphere, and that means that we have to have something really lightweight for us to overcome that mass to generate enough lift. And, you know, kudos and thank you very much to our friends over at Air Environment who designed and built this custom rotor system that is super lightweight. Each blade is less than 2 ounces made of composite material for that very reason. And it spans the distance. The wingspan of this helicopter is 4 feet tip to tip. So that's 1.2 meters. That's super large for something that's essentially carrying the size of a tissue box, just to give you a frame of reference. And in addition to that, generating enough lift involves having high RPM. So we're flying on an average of 2,500 RPM. 2,500 RPM. I just want everyone to sit with that for a minute, because here on Earth, helicopters go 400 to 500 RPM. So that is so much faster, Taryn. It's incredibly fast, incredibly fast. Every detail on this vehicle is made and designed for it to be the most efficient.
You're beginning to see data products. We will continue to watch data products as the full set comes in.
All right, Taryn. Well, we just heard from Michael that they are taking a look at the data just starting to flow into the Deep Space Network antenna on Earth. What happens now that the rover has started sending that data?
3:40
Yes,
in the morning.
So for those of you at home, the Deep Space Network is our giant communications network.
The downlink, early indications, data products look nominal.
Excellent. We'll continue to wait for the full data set to arrive. In the meantime, I'll explain a little bit about the Deep Space Network, and that it's our main communications tool to talk to our Ingenuity helicopter from across our solar system. So our downlink lead just announced that data products have just started to arrive, and that they look nominal, which is a good indication. While we wait for the full data set to arrive, we'll wait. I guess that's what we'll do. We'll wait in the meantime.
And we'll answer another social media question along those lines. Jose on YouTube asks, how long does it take for the video signal from the helicopter to reach Earth?
Sorry, can you repeat the question?
Yes. How long does it take for the video signal from the helicopter to reach Earth?
Yeah, so that goes into having that very long distance between Earth and us. So Ted touched on this a little earlier, and that's why we have this delay. So the helicopter flew earlier, and similarly, whenever we send data, it's the same process where there's going to be a delay of when we run the data and then when it hits Earth. So it's about 4 hours from when something is executed to when we receive it. For larger files, though, sometimes that can take longer. So it all depends. But today we'll be receiving still images of the helicopter.
And I know we are eagerly anticipating those images. And we talked a little bit about this before, Taryn. We have been just floored by all the great images coming in from Perseverance, but Ingenuity has cameras as well.
Absolutely. The helicopter is equipped with 2 cameras. One is our onboard navigation camera, and that's the image that we'll receive tonight. And that's going to be a black and white image that's pointed straight down at the Martian surface, and will hopefully be showing us hovering above it. Our second camera is our return to Earth camera, and that's our higher resolution camera that is a color photo and shows more of the Martian horizon snapshot, the beauty shot, if you will. And then that image will be utilized for future flight missions.
And we have another great social media question here from Hing on Facebook asking, what is the biggest question this first flight will answer about aerodynamics on Mars?
Well, the biggest question that we had to answer when embarking on this was, can we lift? Can we generate enough lift and fly in a Martian atmosphere? And I think this first flight will indicate that for sure. It will answer that question. And whatever we receive back will definitely give us more information moving forward, regardless of this first flight or potential other outcomes.
And we've got another question on social. Waki on Twitter asks, happy flight day. Why are the blades shaped the way they are?
That's a really great question. So in order to generate enough lift, each blade, I mentioned that these were custom designed, and what we call them are airfoils. And they're developed in a way so that it generates enough lift for us to fly and have enough thrust underneath of our helicopter vehicle. So they have that funky shape because of the aerodynamic elements that help it generate enough lift.
And once again, reminding everybody that you guys are controlling this from over 100 million miles away here on Earth. I always try to wrap my head around that.
Absolutely. It is so far away, and it's miraculous to even think that this is something that's technically already been executed earlier today. We're just kind of standing by and waiting for that data to arrive to indicate, success.
Well, we are going to have minimal commentary during this time as we're going to let you enjoy this experience with the team as they go through all the data to see how Ingenuity did. So let's head to the helicopter control room.
And at this point, they're still waiting for the rest of the data to come in to give it an indication whether or not the helicopter actually survived or not. Now, what they're looking at, Earth compared to Mars, is atmospheric density and enough pressure. We are great. We have enough atmosphere here in order to make our craft lift and lower, because we have atmospheric pressure. We have certain airfoils that allow the air to travel up and downwards. In a helicopter, their blades are kind of concaved in order to generate lift, to push the aircraft up. There has to be enough rotation necessary to get a wind effect going in order to get that pressure downwards. Because of lack of pressure compared to Earth, they need to generate a hell of a lot of steam. There we go.
Begin processing shortly.
Well, we got something in.
This is Downlink. We are beginning to fetch data from Mars 2020. This is Downlink. We have pulled in data products from Mars 2020.
Right. It's raw data, and I'm a raw person. They're looking at number crunching. Certain numbers and certain values.
Downlink, confirming we received Mars 2020 telemetry, confirming that we received Mars 2020 events, confirming that we received helicopter data products, confirming that we have data products, confirming that we unpacked image and 1 Hz data.
It may look like Google, but it isn't Google that they've got on the screens. We have head nods left and right, but we haven't heard any cheering yet. It's a small group. These guys are in their 30s, 20s and 30s, engineerings, and every other PhDs you think of regarding mechanical engineering and science. And this is where we're dealing with the mechanics in an atmospheric condition. If there's sufficient enough atmosphere to create pressure to lift.
Downlink, we have successfully ingested 1 Hz data. Confirming that we have helicopter data products, helicopter telemetry, helicopter events. Confirming helicopter file listing. Confirming expected boot counts. This is Downlink, confirming battery data has been received.
Okay. Confirm is information sent over to them. Down
Rotor motors appear healthy. Swash plate servos appear healthy. Overall actuators appear healthy.
Confirming thermal report generation. Confirming analog report generation.
What they're trying to find out is whether or not if the craft actually lifted up, did its job, came back down without any issues. Boil it down.
Confirming telecom report generation.
what they're talking about, Deep Space Network, is we have radio telescopes all around the planet.
Is the downlink handing off to flight control for telemetry analysis?
Downlink's already got the information, it's sending it over to flight control. They're going to be figuring their damn stuff out, whether or not we've actually got.
Is flight control confirming that we have DVRs from Ingenuity? Ingenuity is reporting having performed spin-up, takeoff, climb, hover, descent, landing, touchdown, and spin down. And altimeter data confirms that Ingenuity has performed its first flight, the first flight of a powered aircraft to another planet.
They did it. They did it. And this is why you double check and triple check your redundancies left and right. You go through every damn testing you can to get results like this. Keep this in mind. This is pioneering ground they're going through. Every time we send a satellite over to another planet, we have to double check and triple check and quadruple check to see everything's running. Now they're getting the pictures. And it's an aerial shot of the helicopter. And they're freaking. And they're rightfully so. Rightfully so. Okay. We're gonna. Okay, here comes
Terry,
stuff.
go ahead and repeat that. So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible!
And that's its shadow, right, Taryn?
Yes, that's a shadow. So the onboard navigation camera points straight down, so we're seeing its shadow right now.
I can just hear Mimi in the background. This is real. This is real. It's so amazing.
Yeah, everyone's really feeling it now. So we're gonna wait for the Perseverance rover image of us.
And I got confirmation. They're getting the visual or still pictures of the aircraft hovering and then landing in one piece. Or Mars craft. It generated enough lift to get itself up in the air, hover, and come right back down.
Saw that, Taryn. So
Now you may think this is a boondoggle,
explain what we just saw with the Perseverance image.
So the Perseverance
but this is important.
image is showing us grounded at first. It's actually a video, which is great. It's grounded at first, and then shows us hovering our 3 meters above the Martian surface and then touching back down. It's amazing, brilliant. Everyone is super excited.
So I would say it's a success. I would say
I got these set up as contingency please, which I never practiced, but I'm gonna do it. But I'm happy for you to have a much broader picture. We can now say that human beings have flown a rotorcraft on another planet. it is. And this project has had many friends who contributed to tonight's success. I see many in the room, the team in the room, team on WebEx, team members who couldn't join us, and a few of our friends who are no longer with us, they're still in our lives today. And Perseverance Drover, the best host little ingenuity could ever have. History doesn't, we don't know from history what Orville and Wilbur did after their first successful flight, the Wright brothers, but I mentioned the two brothers helped each other. Well, you know I'm hugging you virtually, and you guys haven't been with me for 4 or 5 years. If it weren't for COVID-19, you guys don't have a chance of me. This is all I can do. I'm giving you the hug. We together, put at Mars, and we together now have our Wright brothers moment. So, you know, history does tell us that soon after that first flight, Wilbur and Orville did go right back to work. They flew 3 more flights that day, harder and further than the first one. So, we know, you know, like the Wright brothers that you have, we know that our time can make a difference. Adventure Crater Mars is not yet over. This is just the first way flight. So let's enjoy this moment. But we must enjoy this moment because over the years, and there are a few of you especially, but there's some that have never let me celebrate fully. Every time we hit one of these major milestones, not yet, not yet. So we must take a moment to celebrate this moment. Really important. Congratulations, everybody. Congratulations. Take that moment, and then after that, let's get back to work and more flights. Congratulations.
Okay, so while they're going to be talking, the thing of it is, we have had many land rovers on Mars. We have never put an aerial craft, and while they're going to be talking like crazy. This is an important moment in history at this point because we have never placed an aerial footage on it. And now we've got it. We have the capability of flying on a planet. Now, it's small steps. The small steps, like what the Wright brothers did, had made this possible. Made this incredible. For the first lander we've put on Mars back in the 70s, concerning about the Viking to this, in my lifetime, we're actually seeing more and more of Mars than any time we've seen, other than putting up a telescope and watching it. But we're talking about deep space networks. There are various radio telescopes out there who are keeping track of anything and everything going on, including signals. We've got friendly satellites that we have on Mars from all the orbiters we have flying around the planet, gathering data from the mobile labs down below, all of our robotic equipment. This is just one of those steps we have of having another milestone added to exploration of another planet, leading up to the point where we're going to be putting feet on Mars, hopefully within the next 20 years. That's going to be the momentous thing, but we need all the information and data we can. Think of it this way. The Mercury astronauts, Gemini astronauts, and the Apollo. Mercury and the Apollo were the superstars. But the nitty-gritty is the satellites we're sending out to get all the data necessary, to get all the procedures and bugs necessary, to get all the photographs and data we can in order to make later trips necessary to where we know where we're going, what we're facing. We didn't know this regarding Apollo. We had to have missions to see whether or not we could actually do these things in orbit. That's why we had the Gemini missions, and those were very important and crucial for man's stepping out into space for America. It is. Russians, well, they just threw them out there because they didn't do it in stages. They just threw people out there and just say, oh, we got the first. But we had to learn the hard way. We had to understand the hard way. We had to go things step by step by step, and this is important. This is important because now we've done something. I'm not going to get back into the mechanics of how it happened, except the point that it actually did happen. There's very little atmosphere on Mars, and we had to use a lot of engineering skills necessary to fly on Mars. We've had a lot of shows and movies concerning about what life on Mars would be like. We're seeing it, the raw images of what our satellites are telling us. Think of it as going through the most rockiest areas of deserts we've had on Earth, but with reddened skies. Because there's not much in the atmosphere for, well, we look at the sky right now for Earth. We have a lot of moisture, we have a lot of oxygen content, we have a lot of different gases that helps us breathe and function. They have different gases on Mars that doesn't support that, but they may have had evidence. We are sending machines out there because we can't go there just yet, but we need to know as much as we can so we can send ourselves out there to learn even more. We need to know if we can survive and live out there, or at least try to function anyway. And it's not going to be easy. This is not like a short trip to Mars and to the moon and back. We're learning more skills and how to survive on Mars for a long time, because it takes a long time to get ships to there, using orbital mechanics and laws of physics to shoot ships to Mars and slingshot them. Not to mention the orbital mechanics as well. Mars has to be at a certain angle where the Earth is coming, so they can shoot rockets to Mars and hopefully back. And this is just another step that we've got with the Ingenuity helicopter. Think of all this as the Gemini mission. All of our robots are superstars, but they're also the Gemini mission because they're the fact gatherers. They're gathering every information until we get the superstars, the Apollo astronauts, out there. Now, I'm using all the ancient terminology here, but we did our shots. We did our first satellites. Those are the Mercury astronauts going up there. Now we have the Gemini program going on. A mechanical. We need every damn piece of data we can until we get our astronaut superstars out there, the Apollos, to actually walk on Mars. And then the fun part is trying to survive on Mars. We've done it. We've done another piece. Now it's time for the other piece.